Hello everyone and welcome back. In this lecture we'll continue our discussion on violin plots. In the examples we have seen so far, these quartiles appear on a vertical line, right? So all the violin plots that we saw, the quartiles appear on a vertical line. If we want, we can also make them appear on horizontal lines as a line. So for that we'll use another attribute known as inner, and all we have to do is set it to be equal to quartile. That way it will appear as a horizontal line. Let's look at an example of that. So SN is the violin plot. Let's consider the same violin plot. So we'll pass day on our x-axis, and for our y-axis we'll use total bill, and our data comes from the tips data set. We'll use hue. What hue did you use? Smoker. Okay, let's use smoker. And then for our palette, let's use cool warm. And then to make it appear as a horizontal line, we'll be using the inner attribute and set it to be equal to quartile. Okay, so if we run this now, so we have a split, we have a paired violin plot with the quartiles appearing as a horizontal line, right, for each of the day variables here. So let's copy this and make another one. This time we'll make a split violin plot. So we'll pass the split attribute and set it to be true. So here we have the quartiles on a horizontal line. So we used smoker as hue. We can use sex as a hue also. So if I copy that and change this to sex, for our palette let's use another color, RGB maybe, and run it. So same thing, we have the quartiles as a horizontal line. Another thing we can do is adjust the width of our violin plots based on the number of observations that we have for each day, for instance. For that we'll have to use the attribute known as scale, and then we'll set it to be equal to count. That way the width of our violin plots will be adjusted based on how many observations we have for each particular day in this case. So let me copy this to save some time. So we have our violin plot. On the x-axis we have day, total bill on our y-axis, data comes from the tips data set, hue is sex, palette RGBU, inner is quartile so that the quartiles appear as a horizontal line, split is true, and let's pass the scale attribute and we'll set it to be equal to count. So if we run this now, so our violin width is adjusted based on the number of observations, in this case for male and female. So if we take Sunday for instance, we have more male customers compared to females, and same thing for Saturday. It looks like for Thursday we have about the same number of males and females. So that's the scale attribute. We can also do that for paired violins. So if I remove the split attribute here and then add scale and set it to be count, See, we see the same observation. So the orange one is for males, and for Sunday we have more male customers compared to females. So the width of the violin is adjusted according to the number of observations. We can also compare smoker versus non-smokers. So if I copy that, paste it here, and change the hue to smoker in this case, and let's change the color to a QSL and run it. So you can make the same comparison. For instance, on Friday we had more smokers compared to non-smokers. Another thing we can do is show each of our observations with a stick or a line inside of our violin plots. So each observation will have a single horizontal line in each of the violin. Let's look at an example of that. For that, we'll be using the inner attribute like this, and this time instead of quartile, we'll set it to be equal to stick. That way it will show us each of the observation for our data set as a horizontal line. So each line will represent a single data point. Okay. So for the sake of time, I will copy this and paste it here. So we have SNS.violin plot. There on the x-axis, total bill on the y-axis, data comes from the tips dataset. Here we have smoker, palette, HUSL, and for inner, instead of quartile, we'll change this to stick. Okay. So we can leave the scale here or not. We'll see two examples, with or without. So we set the inner attribute to stick. So here you'll see a bunch of horizontal lines for within each of the violin plots, within each bin, and they represent a single data point. So one line is a single data point. For instance, if we take Sunday, we had more non-smokers. So here we can, it gives you another comparison, right? You see more horizontal lines in this green bin compared to this red bin, right? And if you want, you can move the scale attribute. So let me copy this and remove scale. I just wanted to show you the difference. So if we run this, now we have a different violin plot with each observation as a horizontal line. You can still make a comparison. The scale one helps you, right? Without even, just by looking at how wide each bin is, you can tell that for this case, we had much more non-smokers compared to smokers for Sunday. So you can tell the difference by looking at the width of each bin. Whereas here we remove the scale attribute, so we cannot predict based on the width, right? That would be a wrong assumption. For instance, if you take Friday, according to this, if you consider the width of the bin, you will come to a conclusion that there were more non-smokers compared to smokers. However, here we pass the inner attribute and set it to be equal to stick. So we have each observation, each data point is represented by a single horizontal line. But we can tell that for Friday we have much smokers compared to non-smokers. So be careful with the attributes that you pass. And we can do the same for male and female customers. We can compare them. So if I copy that, paste it here, for hue instead of smoker, let's pass sex, and for our inner, yeah, let's leave everything else like that. So male is represented by this red color, female we have green for each particular day. Another thing we can do is, or before that, so here the examples are paired violins, and you can also pass the split attribute to have a split violin. So we can set the split to be equal to true, and we have a split violin. Great. Another thing we can do is we can compare the widths across all of these days and then adjust it accordingly. All we are doing here is, for instance, if we take Thursday, we are comparing male customers versus female customers for that specific day, and then adjusting the width of the bean or the number of lines, right? Another thing we can do is compare the male customers and the female customers for Thursday and versus all other days, and then adjust the width of the width of each bean to say and compare the number of customers that we have for a specific day. For that, we'll be using the scale hue attribute. Let's look at an example of that. So if I copy the above, so I copied that, we have day on the x-axis, total bill on the y-axis, data comes from the tips dataset, hue is smoker, palette HUSL, we have inner as stick, scale is count, and we'll pass one more attribute known as scale hue, scale underscore hue, and we'll set it to be equal to false. Now if I run it, we get this result. So what can we say from this graph? We can say that there were, first of all, there were less customers on Friday compared to the other days. We can tell that by looking at the relative size or width of our beans, right? So here, the widths of our beans are adjusted by comparing them to all the remaining days. Okay? And let's make the split for more comparison. So we'll set the split attribute to be true. Run it again. Well, that's what we can tell. We had less customers on Friday, and then Thursday we had more customers, probably on Saturday or Sunday. We can say we have the most non-smokers on Sunday, right? And we can say we had the most smokers on Saturday. We can tell that by comparing the width of the bean, okay, across all the days. And we were able to do that by passing the scale hue attribute and then setting it to be false. And we can do the same thing for the sex as hue. So instead of smoker, let's pass sex and compare it. So we have male in red and female in green. So if you compare, if you just take the female customers across all those days, we had the most female customers probably on Thursday compared to Saturday, maybe Thursday or Saturday. We can find that out by counting the number of lines. That's one way. But just by looking at this, we had the least female customers on Friday, and for male customers we had the most, it looks like maybe Saturday or Sunday, right? So that's the scale hue attribute. And there's also another attribute known as bandwidth, and for that we can adjust the bandwidth of our beans. Okay, I just wanted to quickly show you that. So I just copied this. That's the same exact thing as we saw above, and let's pass the bandwidth attribute BW, and let's set it to be equal to, let's say, 0.7 maybe. We can adjust this. So that's what it looks like. A bandwidth of 0.7. If we copy it here and pass another bandwidth of maybe, let's say, 0.1. This is what it looks like. So we can adjust the bandwidth for our Violin Plus. I just wanted to show you that, but you can play around with the bandwidth by setting it to different values and see the effect on our Violin Plus. Great. Just to summarize, we looked at Violin Plus in this lecture, and we saw that we have various kinds of attributes that we can use to get more information from our Violin Plus. Great. Thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the lecture on strip plots. As usual, we start by importing